Okay, welcome back. Now we're going to manage quality, just the outputs. Then we're going to discuss control quality quickly. I want to get on to control charts and have that discussion with you. So in outputs of managed quality, there are quality reports, which are graphical, numerical, or quantitative, and you use them to take corrective actions. Test and evaluation documents are referred to. These are inputs to control quality processes that are used to evaluate and achieve quality objectives. Okay? They may include checklists that you've developed or requirements traceability matrix, for example, things like that. Change requests we've talked about many times already. Quality management plan updates, including the quality management plan. That's one of the things you would consider updating. The scope, baseline, schedule, or cost. So the performance measurement baseline, in essence, the PMB. And then project document updates. If you found issues, you likely will, you'd add it to the issues log. If it's in a closed item, you'd add it to the lessons learned register, or maybe the risk register if it's a new risk. And here's a sample issues log for you. Notice I have at the end on the right my resolution comments updated. Did I reply back to the stakeholder that brought up the issue? I think that's very, very important. Okay, and it's used to manage. All right, now we have managed quality versus quality control. So managed quality is about implementing, remember the execution process group, implementing the quality standards and executing the steps in the process improvement plan. Now, in quality control, it's this product oriented. It's about the engineering aspects or other key attributes of quality, and we're going to focus on defect repair. So in quality control, the outputs, these ensure the outputs are complete, correct, and meet customer expectations. A term I like is correctness. Are they correct? Are the results meeting engineering specifications or technical order requirements? Okay, so here we formally demonstrate with reliable data the acceptance criteria have been met. Okay, that the product is fit for use. We talked about that earlier. That was Gerand. Is the product fit for use? That comes into play here in quality control. Okay. There are inputs listed on this slide, including the project plan and documents. Notice approved change requests are an input here. Okay. Approved change requests are also an input in the execution process group in the process in integration management knowledge area in the process called direct and manage project work. It's one of your processes as the project manager. And so here now we see again approved change requests. These may include modifications such as defect repairs or revised work methods or revised schedules, for example. Okay. Deliverables are an input, so if I'm going to before I can check it out for its exactness, I have to have my deliverable. And the deliverable is defined as a unique verifiable product or result or capability to perform a service. This is what comes out of, this is an output from direct and managed project work. So there are now two inputs here that are directly tied to direct and managed project work process. And then work performance data. Whenever I'm in the control processes outside of integration management, all the other control processes, I always have the plan in, documents as an input, work performance data, EEFs, and OPAs. If you think of it like that, there really aren't too many, and approved change requests and deliverables make sense in quality control. Okay. Now I'm going to look at the tools of quality control. Those begin on page 302 and following. There are checklists or check sheets. There's a check sheet on the right. Sometimes it's called a tally sheet. I used that when I studied delays in Ramstein, Germany, when I worked there, airport delays. What caused the delays? because my boss had me spending a lot of time studying delays and briefing them monthly. And after 3 months of data collection, a tally sheet, I determined that 95% of all delays were outside of our control, and that we were spending a lot of time managing something that wasn't our fault. The delays were due to weather, which was outside of our control. The delays were due to quiet hours, which is a German imposition upon our operations. They see noise as pollution, and so I can't control that. And a few other items, all outside of our control, almost all, and my boss conceded based on the tally sheet that I used. Then we have data analysis, which has performance reviews and root cause analysis. We talked about that in section 8.2.2.2. Inspection, we said, was a tool. It was also a tool in validate scope, which is another control process, except in scope management. Inspection includes measurements. And we said you can do quality control inspection and validate scope inspection at the same time. You would never do validate scope first. You would either do quality control and validate scope at the same time, or you do quality control first. You need to know that the product works before you show it to the customer. Okay. Then we testing and product evaluations is another tool, and then data representation. We're going to talk about these next. These couple. Okay. So some quality control tools, data gathering. Data gathering can use statistical sampling. How many times are you going to inspect something? You don't always need to inspect, or sometimes you can't inspect to 100%. So we do sampling based on reduced sampling, and it would follow Frankly Deming's Plan, Do, Check, Act, or PDCA again. Okay? And those are some of the steps you might use if you wanted to do that. Now, in quality control tools, under data representation, we have control charts. So we'll spend just a few minutes talking about control charts. And because control charts tell you when you are in the acceptable limits. And we're going to talk about natural variation, which is okay. All right. The symbol for a sigma is listed there. It's kind of the O with the line on top. That's sigma, or standard deviation. There are others. There's 6 sigma, 4 sigma, etc. Right now, we're just going to look at 1 and 3 sigma, which is 1 standard dev, or SD. It means that all the data points are going to fall within 1 standard dev from the mean, from the average, or 68.25% of all data points are meeting acceptance criteria. Is that good enough? Well, maybe. What if I'm making a dollar store toy? Does it really always have to work? It's only $1. How much more quality do we want to put in it? Are you likely to return it? As long as it's not a choking hazard or made from some material that causes physical or health issues, then it's probably good enough. So it can be used in various degrees. Mean is referred to as the average, and you see that in the chart on the bottom, the dashed line in the middle. The standard deviation is a measure of a range or variation. How far from that dashed line or that mean can I get and it still be acceptable? Okay. So I'm showing you between the dashed lines. So the dotted line is the mean. The dashed lines are the acceptable range of variation, upper and lower limits. And that's what I refer to as UCL and LCL. Okay. The rule of 7. So anything that's above the upper control limit or below the lower is called out of control. Okay. Also, there's something called the rule of 7. I can be within the control limits, but have 7 data points come out together. There isn't natural variation, and that means it's also out of control. And we're going to assign a cause code to that, or special cause variation, which means we're going to investigate why. The picture there is, not the FIU bridge collapse. That's actually the Southwest plane engine that came apart. And I imagine they will be doing some control charts on that variation is allowed, but how much? And they may tighten the upper and lower control limits. That's just my guess. The investigation is underway. Here's a bigger picture, another view of the same control chart. You see the mean in the middle with the dash limit and my acceptable variation. And you see how my lines go up and down and up and down and up and down. That's natural variation. That's life. That's how life works. So are there any assignable cause codes here? No, because everything is within the upper and lower control limit. When a plane goes on autopilot, it actually doesn't fly level, though it feels like it. It actually porpoises across through the air to its destination. You don't feel it because the upper and lower control limits are set very small, but it is actually doing it. It's acceptable. It's normal. So that's called a normal distribution. All right. Then we have this acceptable range of variation that we just talked about there. And then we have a specification limit that's defined as something the customer sets. So the customer may have said, hey, you know what? I need quality to meet this level. So in B as the PM, I'm going to go, well, okay, I'm going to put my lower control limit just above that and my upper slightly above that. Not too much higher because it costs a lot of money. That range will be acceptable. But the customer set a limit I have to meet. Now, I just added a line, gives me a data point. Is it still, are there any assignable cause codes? Well, now the answer is yes. Yes, there are. It's out of control because it's above the upper control limit. That is no longer natural variation that I'm willing to accept in this process. Also, I mentioned the rule of 7. You see how otherwise I have natural variation up and down? Well, what if I had 7 data points all stay above the average? That now gets a cause code also because it is not natural. Variation is natural. I'm just trying to define how much I want. This is not natural. Something is amiss. And so the rule of 7 is called a heuristic. It's a rule of thumb by other terms. Okay? And so it's out of control. Assign a cause code. Normal cause, or they call it common cause. I'm not assigning a cause to it. Is on the right, those dots. That's natural variation. Okay. So here are some quality terms and concepts to review for this lesson, including just in time. ISO 9000 is a quality management system of standards that is by the ISO organization, the International Standards Organization. Be aware of that. And who is responsible for quality? Well, the PM is ultimately responsible for quality in the project. Everybody has a role, but management has a key role. And finally, here's a chart that shows, you don't need to know this whole slide. It's called defects per million opportunities, DPMO. You see the mean. So this was that control chart, but now it's flipped upright instead of on its side. And you see one standard dev plus or minus means my data points, it's acceptable. If everything falls within one standard dev, or my data points, I would expect 68.27% compliance. But what is memorizable for the PMP exam, if you're going to take that, are the 1, 2, 3, and 6 sigma percents. 6 sigma is 99% quality. I give you some extra data for fun. It's 2 errors or issues or defects out of every million outcomes. 3 sigma is 99.73. That's what's important for the exam. I just mentioned that it's about 27 errors out of a million items. 2 sigma and 1 sigma. Also note, 3 and 6 sigma are common upper and lower control limit numbers pending other data. Okay, that is it. I hope you enjoyed quality. We'll move to resource management.